Al-Marifa International Private School, IGCSE 0625, Thermal Physics. Liquid and glass thermometers. Thermometers are usually used in lab to measure temperatures. Using liquids such as mercury or alcohol filled inside the bulb that is contain already mercury or alcohol, colored alcohol, which expand when the temperature increases and contract when the temperature decreases. So the basic parts of thermometer, they are bulb, where the mercury and alcohol, colored alcohol placed. Then we have capillary, glass capillary, and we have scape. So as you see, we have small bulb here. It is contain the liquid, which is mercury or colored alcohol. Then we have the glass capillary, this one, the glass capillary, and we have the scale. These are the basic parts of thermometer. As you see here, we have two thermometers. This side to measure the temperature in Celsius, this side to measure the temperature in Fahrenheit. Now, when you place this thermometer inside a hot object, the mercury inside will expand and increase its volume. So it starts to raise up inside the capillary. Now, this thermometer shows that the temperature is between 45 and 44. When you place the thermometer inside a cold object, the liquid inside the bulb starts to contract. As well, it will show low temperature. As you see here, it is -20. So, this is the function of thermometers which are using liquid and glass, such as alcohol and mercury. Now, to calibrate and design a thermometer, we have some steps. I'll show you what are the steps that we have to use and to do to calibrate a thermometer. See this simulation. In this simulation, we have not a scaled thermometer, we have pure ice, and we have pure water. Firstly, we have to place the unlabeled thermometer inside the pure ice. When we place this one, the thermometer, inside the ice, the pure ice, as you see, the mercury contracts and it will stop until 0 Celsius. So, in this time, we have to mark the 0 Celsius on the thermometer. Now, we have 1 degree, which is 0 Celsius. And the name of this degree is the lower fixed point. This is the temperature of the pure melting ice. This is called 0 Celsius or 0 degree Celsius. Second step, we have to remove the thermometer and place it inside the pure water. This is the temperature of the steam above the pure boiling water, the steam above the pure boiling water. Now, as you see, the mercury expands until reaching 100. And the 100 is named here by the upper fixed point. In this way, I have to mark this 100 on my empty thermometer. So I have two marks. First one, the lower fixed point, which is 0 Celsius, which is the pure melting ice temperature. The second point is 100 Celsius, or the upper fixed point. and this is the boiling point of the steam above the pure boiling water. Now, when we remove our thermometer here, I will use the division between 0 and 100. So if I have this distance from 0 Celsius to 100 Celsius, easily I can divide the scale into 100 equal divisions. By this way, I have a skilled thermometer with a proper capillaries. So the scale, once you have the 0 Celsius and 100 Celsius points, you have been fixed on a thermometer. The rest of the scale is made by dividing the space between the points into 100 equal divisions or degrees. This is called calibration of the scale. The idea can be extended to produce temperature scale going above the 100 and beneath the 0 Celsius. So this is the way to calibrate a temperature, the temperature of thermometer. Return back to our slides. Now, so again, the calibration of a Celsius thermometer, as we said, we place this one inside a pure ice, then a pure water, boiling water, then divide the distance between 0 and 100 equally. And we can extend this idea to have 120 as well and negative 20. Now, as you see in liquid and glass thermometers, it consists of thin capillary tube that is containing of a liquid that expands with temperature. At one end of the tube, in a glass bulb containing large volume of liquid which expands when heated, moving into the narrow tube. A scale along the side of the tube allows the temperature to be measured based on the length of the liquid within the tube. As the bulb is heated, the liquid expands and moves along the capillary tube, and the opposite is right. As the bulb is cooled, so the liquid contracts and moves down the capillary tube to show high temperature and low temperature. Look at this question. To check the accuracy of a Celsius scale thermometer, which beakers should the thermometer be placed in to check the lower and the upper fixed point? Justify your answer. In beaker A, we have mixed ice and salt. In beaker B, we have mixture of ice and water. In beaker C, we have boiling salt solution. In beaker D, we have boiling water. Which of the three, which two of the four are suitable to measure the two fixed points that we needed to calibrate a thermometer? The answer, the mixture of ice and water, which is 0 Celsius in beaker B, represents the melting phase of water, and so is suitable to check the lower fixed point of thermometer. The boiling temperature of water 100 Celsius in beaker D is suitable to check the upper fixed point of the thermometer. Return back to our question. So, first one, beaker A, is suitable to calibrate the temperature of the lower fixed point, which is 0 Celsius. Also, beaker D is the one that is suitable to calibrate the upper fixed point, which is 100 Celsius. So the answer A and D. Now, measuring temperature, usually we use two fixed points. The lower fixed point, the melting temperature of ice, and the upper fixed point is the boiling temperature of pure water. Now, what are the features and the properties of liquid and glass thermometers? Usually, we have three features or three properties. Number one, sensitivity. Number two, range. Number three, linearity. So again, sensitivity, range, and linearity. So to have good design and efficient thermometer, we have to balance between the three properties: sensitivity, range, and linearity. Now linearity. Now the scale is said to be linear when the expansion of the liquid due to the temperature increase of 1 Celsius the same at any temperature. So linearity is there in a thermometer if the expansion rate of the liquid and the bulb of a thermometer is expanded in a constant rate every one increase of temperature 1 Celsius. So if the expansion rate is constant every 1 Celsius, so we can say that the thermometer is linear. Now, as you see in these two figures represent a linear liquid used in a bulb of thermometer and non-linear liquid used in a bulb of thermometer. As you see here, the expansion rate, because of increase in temperature, every 1 Celsius, the same distance expands 1 to 2, then same distance 2 to 3, same distance 3 to 4. So the expansion rate is equally every increase in temperature 1 Celsius. While here, every increase 1 Celsius, the expansion rate is differ from one time interval to other one time interval. So as you see at the beginning from 1 to 2, see the distance of expansion from 1 to 2. It is more than the expansion rate from 2 to 3. And 2 to 3 is less than 3 to 4. So this liquid that is used here in a thermometer is not linear, and here it is linear. So this is the property of linearity. Linearity is said to be linear when the expansion of the liquid due to temperature increase of 1 Celsius is the same at any temperature. So this is linearity. Second property. This graph represents the relation between volume of the liquid expansion and temperature. As you see, it is linear. So when it is a straight line, so we have linearity. Expansion rate is constant for every increase in temperature or decrease. Second property, sensitivity. Sensitivity is the amount of liquid expansion corresponding to very small change in temperature. Now, sensitivity can be increased by two actions: increasing the volume of bulb or decreasing the diameter of capillary. Again, the sensitivity can be increased by two actions: increasing the volume of the bulb or decreasing the diameter of capillary. Now, sensitivity means precision. How do you think this will affect the sensitivity? We said that decreasing the diameter of capillary will increase the sensitivity. Now, we have here two capillaries of two thermometers. This one is wide, this one is thin. Now, for the wide one, the precision is 2. For the thin one, the precision is 1. So B is more precise than A. That's why B is more sensitive. So sensitivity affects precision. So if the diameter is less, precision is high. So this is the second property of a thermometer, where the expansion is quickly and sensitive for any increase in temperature. Third one, range. Range is the lowest and highest temperature the thermometer can measure. So range is the change in temperature between the lowest temperature and the highest temperature. So the range can be increased by smaller bulb, wider capillary. These two actions can increase range, smaller bulb and wider capillary. And if you see here, the range to improve range in a thermometer actions are opposite to sensitivity. So sensitivity and range, they are opposite in the actions of improvement them. Also, the liquids inside the bulb, they have range. For example, mercury can measure a temperature between 35 negative 35 to positive 510, while alcohol measures a range between negative 80 to positive 70. So range is the difference between the lowest temperature and the highest temperature on a thermometer. And every liquid inside the bulb of a thermometer also has a specific range. Now, the actions to improve range, they are opposite to the actions of improving sensitivity. Now, look at this thermometer. Now, the range of this thermometer is between, I will take only the Celsius part, 35 Celsius and 42 Celsius. As you see here, what is the range in this thermometer? 42 minus 35, 7 Celsius. So the range of this thermometer from the Celsius side is 7 Celsius. Now, in this image of this question below shows a liquid in a glass thermometer, which two parameters of the thermometer should be changed to make it more sensitive. So what are the two actions, permanent actions, that we have to make it to improve the sensitivity of this thermometer? The answer? The greatest sensitivity will come from a small change in the volume of the liquid, so a small bulb, when heated, causing a large change in the level of the liquid in the tube. So if we decrease the volume of bulb, we will decrease the volume of liquid inside the bulb. That's why the level of we will have more change in the level of the liquid inside the capillary tube. Second action, a large glass bulb also and very small narrow tube will improve the sensitivity of the thermometer. So again, the greatest sensitivity will come from a small change in the volume of the liquid. So when heated, causing a large change in the level of the liquid in the tube. So large glass bulb and very narrow tube will improve the sensitivity of thermometer. These are the two actions. Now, the summary of the properties of thermometer. First one, the sensitivity liquid thermometer. The liquids used in liquid in glass thermometers are chosen for their thermal expansion property. The two liquids, they are mercury and alcohol. They expand in a linear way with temperature. They expand to give greater amount of sensitivity or a greater rate of sensitivity. They have low freezing and high boiling point, allowing them to be used over a greater range of temperatures. The use of a large bulb coupled to a very narrow tube also results in a greater sensitivity, as a small change in volume results in the liquid moving, and this is inside the tube. This is the summary of the properties of thermometers. Look at this question from past papers 2014. The liquids in 5 liquids in glass thermometer A, B, C, D, and E expand linearly with temperature. All the thermometers have scale marked in Celsius. Figure 6.1 accurately represents the scales of these 5 thermometers. Question AI. Use information from scales of the thermometers in figure 6.1 to state which thermometer has the greatest range. Now, to have or to measure the greatest range, we said we have to subtract the highest measuring point and the lowest measuring point. Now, for example, 45 minus 30 is equal 15. So the range for E, for example, the range for E is 15 Celsius. D, the range is 300 minus 100, it is 200. So E is 15, D is 200. Now the range for C, it is 50 minus 0, so the range is 50. Now for B, 100 minus 10, the range will be what? Will be 120. Now for A, the range is 250 minus 50, the range is 300. So as you see in question AI, they asked about which one is the greatest range. When we measure the ranges for all, the greatest range was for A. So A is the highest range between the 5 thermometers. Now question 2. State and explain which thermometer has the greatest sensitivity. Now we said that sensitivity is opposite to range. So the one that has the lowest range has the greatest sensitivity. That's why E is the one that has the greatest sensitivity and A the greatest range. Now, B, suggest to design features that would cause a liquid in a glass thermometer to have a large sensitivity. To have a large sensitivity, we have 2 actions. Increase the volume of the bulb and decrease the diameter of capillary. Again, the answer of B, increase the volume of the bulb, decrease the diameter of capillary. Now, advantages and disadvantages of using alcohol inside the bulb of thermometer. Now, advantages of alcohol inside the thermometer. First one, it can measure a low temperature because its freezing point is low. The freezing point of alcohol is negative 115 Celsius. That's why it is suitable to measure the low temperatures. So this is one of the advantages. Second one, it can measure the temperature, yes, in a precise way because it has large expansion coefficient. Third one, it is expansion in a regular way. So these are the 3 advantages of using alcohol in a thermometer. Now look at the 3 disadvantages. First one, it can't measure high temperature because its boiling point only 78. So this 78 is very low temperature, so it can't measure any temperature above 78. Second disadvantage, it makes wet the wall of its place. This is the second disadvantage. Now the third one, it is colorless. So it must be given, yes, so dye stuff in order to be visible. So we have to color the alcohol to be visible. These are the disadvantages and advantages of alcohol. Now, mercury. The advantages and disadvantages of mercury. The advantages, it is visible since it's colored by silver color. Because it is colored in silvery shining color, yes. Its expansion in a regular way. does not make any wet on the wall of capillary. It can measure high temperatures because its boiling point 356.9 Celsius. It can measure the temperature quickly and in a precise way. These are the advantages of using mercury in a thermometer. Now the disadvantages. It can't measure very low temperature since its freezing point only -40 Celsius. Mercury, the second disadvantage, mercury is poisonous, so it is harmful. It is tube if the tube for sure broken. Third one, the price of it is high, so mercury is expensive. These are the advantages and disadvantages of mercury as we use it inside the bulb of thermometer. The second device to measure temperature is thermocouple. Thermocouples are electrical thermometers. The thermocouple use the property of electricity, which is voltage created when two different metals are in contact. This voltage varies with the temperature. Now, this is the structure of thermocouple. We have two wires, iron and copper. Iron and copper, they are joining from the two ends, this end and this end. Copper is connected with milligalvanometer or millivoltmeter. Now, the first one, this one, the joining point between copper and iron is placed inside pure ice, and we call this by cold junction. And the second meeting point between the two wires is placed inside hot water or hot object. So we call this side by hot junction. So cold junction and hot junction. So when we have this difference in temperature between the two junctions, we will have potential difference between the two wires. That's why we will have voltage that will be shown by the millivoltmeter. So when we have difference in temperature, we have difference in potential energy. This difference in potential energy will be shown by a number in the voltmeter. So the voltage measured by the millivoltmeter will reflect how much is the difference in temperature between the 0 Celsius here, which is pure ice, and the other unknown temperature in the hot junction. Now, the voltmeter will show you the voltage, not the temperature. But we know the corresponding temperature for every voltage. Now, when we have two junctions with same temperature, so the voltage will be 0. The voltage or voltmeter or galvanometer will show a value only if we have difference in temperature. So, as you see, thermocouple does not measure the temperature. It measures the difference and the change in temperature by voltage. So the voltage will show us how much is the temperature of the other unknown object. Now, here is the summary of thermocouple work. Thermocouple also is called thermal junction since it is used two junctions, hot one and cold one. It is a measuring device consisting of two wires from different metals, copper and iron. One junction is a place where the temperature is to be measured, and the other one kept in a constant lower temperature, such as pure ice, 0 Celsius. Now, as you see, here is the manufacturing thermocouple and industry and market. This one is digital one. So as you see on the screen, we can see the temperature automatically without any convert from voltage into temperature. So as you see here, this digital one, we have the two junctions, and the digital one will show us the temperature automatically by this device. Now, thermocouple consists of two different types of wires attached to each other. When the joint between the two wires is heated, a potential difference or voltage is created between the two wires. The greater the temperature, the greater the potential difference. So the relationship between temperature and voltage is directly. Thermocouple are not as sensitive as liquid in a glass thermometer. But because the metals have high melting point, they can be used to measure very high temperature. Thermocouples also very responsive to rapidly change in temperature. So these are the two features of thermocouple comparing with liquid and glass thermometers. Now, at the end of thermocouple's thermometer is suitable for measuring very high temperature and very low temperature. Thermocouple relates a change in voltage to change in temperature, and so can respond almost to temperature change, while in a liquid and a glass thermometer, the liquid in glass thermometer bulb must first heat up and then expand, causing a delay in thermometer reading. So these are the main differences between thermocouple and thermometer. Thank you. The end.